Okay, so in the previous video, we understood what are embeddings, right? Now it's time to take a look at vectors and vector databases, right? So the thing is that a vector database is a type of database which is designed for storing, indexing, and querying the vectors, which are arrays of numbers representing the data in a high dimensional space, right? So now the thing is that if I take you back to what we learned with embeddings, in embeddings we learned that if there was a word like a cat, with cat we were able to get the features of that, and against each feature we were giving a number against it. Now these set of numbers, we call them as vectors. Now all you are doing is you are storing these numbers or set of numbers or array of numbers or embeddings into a database, and this database is known as a vector database. Now you can imagine that if I'm talking about, let's say, Oracle, right? Oracle MS SQL Server, you were storing tables or you were storing the relational data in this. But with vector databases, you are actually storing vectors or embeddings or these array of numbers. Now again, here if you see in this diagram, we are considering different types of inputs. Now it could be a document, right? It could be a picture, it could be a sound, right? It could be a video file. So all you are doing is you are taking it or passing it through the transformer. If it is a text document, you are passing through the NLP transformer. If it is audio, then audio transformer. All it is doing is it is generating a certain set of numbers or embeddings, and these vectors or set of numbers are getting stored in the vector database. So obviously if something is stored in a database, you would be using it for querying, right? And you would be storing it, you would be putting some indexes to make your queries faster, and you'd be making say searches on this data, right? So the purpose is that primarily used for storing embeddings that represent the complex data like images, text, audio in a form that machines can understand and process. Very simple. I think I told you in the previous lecture as well. That was the whole purpose of doing embedding, because you were breaking a complex object into smaller set of objects or sub-objects or features, right? And like we took an example where we saw from 7 dimensions, we were able to go into a 2-dimensional space, like where we talked about the example of a cat. We were having 7 different features. The 7 dimensions were converted into 2 dimensions. And the purpose is simple. You're storing the embeddings that represent the complex data, right? And why we are doing it? We are doing it for similarity searches. Like, is a cat related to a kitten? How close are they related to each other? Or if a man is related to a woman, is a king related to a queen? Like, these are the kind of similarity searches we are talking about, right? So vector databases are optimized for similarity search, which allows quick retrieval of items that are most similar to a given query, right? The examples I gave: cat, kitten, man, woman. And there are several kind of options available, which is you could use the Euclidean distance or the cosine similarity. So there are the different ways in which you can do similarity searches, right? It is just looking at where the vector actually stays in your 2D space. So it is actually widely used in machine learning, artificial intelligence, and recommendation systems. So even recommendation systems, we talked about Netflix a lot. So over there also embeddings, vector databases are being used. Because wherever you have to do a similarity search, right? In a Netflix model, you are actually definitely doing a similarity search where you are looking for what kind of movies do you like to watch, right? It's a kind of a similarity search. It is designed to handle large volumes of data and support scalability and efficient querying in big data applications, because we are kind of breaking a complex object or a big object into smaller, set of numbers, you can call it. That's why it can easily handle large volumes of data. And yes, the vector databases can be integrated with machine learning models, which help to directly store and query the model generated embeddings, right? So the key takeaway is that most of the vector databases that are available today, they can be integrated with your machine learning models. And they are capable of providing real-time search and retrieval performance. So as we just studied, that you can easily query in real time. So let's say you have loaded some data or you loaded some objects, so in real time you can perform some searches, and they are quite performant in terms of the retrieval that they do, and they're essential for the interactive applications and services. So just like a normal databases where just you're querying your data from the tables, here you'd be querying your vectors, and the purpose is nothing but to achieve the similarity, right? You're looking to do a similarity search. So with this, we come to the end of vector databases. In the next video, we will try and understand a relation between embeddings and vectors in vector databases. See you in the next video. Thanks for watching.